Subscribe to Amcode and ring the notification bell to get the latest content.
Hello and welcome back. So now let's shift our focus on one of the most hottest topic of the data world, which is Apache Kafka, which is used for handling the real-time data. So without further ado, let's get into it. So before jumping on to the architecture and how it works under the hood, let's talk about what really is Apache Kafka. So Apache Kafka is nothing but an open source. Open source means it's freely available and anyone can install and use it for their real-time use cases. Then it's a distributed event streaming platform. So distributed means that it is scaled horizontally and it works on the commodity hardwares working in parallel and integrated using the distributed network. And also it's an event streaming platform. So event means you can say it as the real-time data coming at a specific intervals, or else it could also work as a message queuing system. So basically Kafka will provide you the real-time data analysis on the go, and that will run on the servers as well as the clients, and it could either be you can set it up locally on your systems or else you can deploy your solution on the cloud platform, because cloud also provides the capability to work with Apache Kafka and deploy your solution there. So basically Kafka's messages are very persistent and also on the disk and replicated within the clusters. So it is similar to HDFS and has some replication factor which provides the data loss, which means that the data will not be lost in terms of any disaster or if any server goes down in the whole process. Then the typical features that are typical use cases of the Kafka will include the stream processing, the stream of the data, and you're processing it to get the quick insight and the nitpick in your data. And also it is used for log aggregation, so you're having like a lot of logs coming in at a real time from any website, then you can do that. Then it can also do the data ingestion to Spark or the Hadoop as well as the error recovery. So it can well integrate with the Spark and Hadoop and store the data and ingest it in real time so that it could be readily available for the reporting purpose or some quick analytics using SQL. So this is just about what is Apache Kafka. Let's take a deep dive in and talk about its basic components and its architecture in detail. So let's talk about the basic architecture of Apache Kafka. So at its core, it has the several components, like the four main components that I have given here. The first one is nothing but the producer. So as the name suggests, it is nothing but used for writing their events. So event means you are publishing your data from the client apps or the topics to the Kafka queue. So basically producer from where you are pushing the data into the topic. So topic is nothing but our next component. So the topics are nothing but are the events that Kafka will store. So you can relate topic as a table in a relational database. So basically producer will produce the data as the name suggests by the client application, and it will publish those events on the topic, and topic acts as a storage layer for all of it, and they are like multi-producer, multi-subscribers. And also topics are nothing but decoupled and have any number of subscribers and can have any number of subscribers. We are going to see it in action in our hands-on tutorial. Then you will able to understand how the producer will publish the events or the data, and how the topic will store the data, and how we can consume it, which will be the next one. The next one will be the broker. So each broker is nothing but a Kafka server. So Kafka server means the broker that will nothing but organizes and sequentially stores the incoming events, or we can say the incoming data which is published by the producer, and it stores them on the disk in the segmented partitions. So partitioning is pretty straightforward term and used in the data community widely, because partitioning is nothing but done everywhere in the data storage solution for efficiently storing all your data, so that it could be easily accessible and well optimized for the read queries. Then you got the consumer, which is the last part of our Kafka architecture. So basically any app can integrate with the Kafka and consumes the data. So the apps that will subscribe to the Kafka topics will nothing but the consumers. So consumers, as the name suggests, will consume the data which is already stored in the topic and which are produced by the producer. Let's talk about it diagrammatically how it works. So as you can see, the topmost layer of our Kafka architecture will be the producer. So producer could be anything. So you can get data from the APIs, or you can say it as you can get the data from the website, or else you can directly get it through a command line. This is just, we are going to simulate this real-time use case in our local machine to able to understand how we can publish the event to some port and how the producer or the Kafka cluster will consume that data. That we are going to see in the hands-on tutorial. But let me brief you about this. So as you can see, the producer will produce the data, then it is stored in the topics. So topics is nothing but stored in the Kafka. Topic is nothing but stored locally on your disk, and each topic will have their own partition. So basically these partitions are also replicated so that if one machine goes down, then you will not face any data loss at all, and it totally depends on what replication factor that you are going to set for your data solution. Then there could be different topics which can store different data, which can store different type of data. It's up to you what type of data you're gonna store in the topic. So basically after the topic consumes the data by the producer, then the consumer apps comes into picture. So basically consumer will consume all the data which is present in the topic as per your needs. This is very simple to understand. We are not going to see in-depth architecture of Kafka. This is just a basic architecture to get a good grip on Apache Kafka, because if we talk about the intricacies of Kafka, you will get confused. So to get you started, let's first talk about how it works, what is like a basic overview and how it works on the high level. Now let's talk about some of the benefits of Kafka, and you may also ask why we are using it, because there are so many tools that can handle real-time use cases as well, but there are some benefits which makes Kafka a good choice for real-time use case. So the first one is the IO operation, which is nothing but the input-output operations, which is nothing but it. So basically non-sequential writing of events to the multiple brokers, or we can say multiple partitions, which will avoid you the input output operation or the overhead which occurs when they are returned to a single partition. So it will make it a very much performant system. So and due to it, it's a good choice for handling big data. Then you got a scalability. So as we already talked about that, it's a distributed storage. So it uses a distributed storage, which is nothing but Kafka will scale horizontally by increasing the number of brokers in the cluster. Brokers, you can say it as the number of servers which are present in this cluster. So server in the layman terms, so it is nothing but a Linux box, or we can say a computer, the commodity hardware in your cluster, and having it horizontal and having it scaling horizontally, it makes it a good choice for the big data applications where the data is coming in at a huge volume. Then comes the data redundancy in the picture. So you can configure Kafka to write each event to the multiple brokers, which makes it a very redundant system and avoids any data loss in terms of any server goes down or else any disaster happens. You cannot tell what could happen. So data redundancy, you should be prioritizing that, and Kafka will give you the capability to improve it. Then we got a high concurrency. Then it also has the low latency, because in real-time use cases where each second is important and not even a second, microseconds is also important to make a decision in the product recommendation system or any machine learning algorithm. So basically it will give you that low latency and the high throughput. So it makes it a good choice for those specific and specialized type of use cases. Then you got a fault tolerant, which we already talked about. Then it has the batch handling capability. So it will having like the ETL type functionality when you are going to switch over to the batch data, where your data is not much needed in real time, and you can maybe do it a hourly basis or the day basis, which is nothing but the batch mode. then it is like persistent by default. So these are some of the benefits of the Kafka and what makes it a good choice for the real time use cases. Let's talk about it in detail and see how the data ingestion happens in the Kafka in detail. So I'll see you in the next one.
So that's it for today. I'll see you in the next lecture.